Claude Code can review your code for security vulnerabilities. And if you have a Claude subscription, it's already included with no extra cost to you. There's also an open source GitHub Action that does this automatically on every single pull request. I planted 10 real security vulnerabilities in a Flask app and ran both against it. Let's see what it catch. But before that, CodeRapid analyzed over 470 open source pull requests and found AI generated code had 1.7 times more issues than human written code. When it comes to security specifically, AI code was 2.74 times more likely to have an XSS vulnerability in it compared to a human written code. At the same time, code volume is exploding. Anthropics says their own engineers' code output jumped over 200% in less than a year by using Claude Code. And before they rolled out automated reviews, only 16% of their PRs had substantial review comments. Alright, I'm in the vulnerable app directory. Let me initiate Claude first. Right, Claude is running. Now, let me start the security reviews. Command is simple, /security-review. It's scanning the code base now. Alright, our scan is complete and it found a bunch of issues. First finding, SQL injection in source.py. Then command injection in network.py. Then we have reflected accesses in greet.py. Now this is interesting. It flagged the admin user endpoint not just as missing authentication but as full data exposure. Here we have IDOR in profile.py. Then we have path traversal in file.py. SSRF in webhook.py. Business logic flaw in cart.py. Race condition in transfer.py. And 10th, finding I didn't even plant on purpose, missing authentication in checkout. Let me run the same scan again. SemGrep also ran a benchmark on an earlier version of Claude Code using Sonnet 4. They ran the exact same scan on the same code 3 times and got 3 different results. Same code, different results. That was an older version. Let me rerun again and see how Opus 4.6 performs. Okay, so this time it only took 47 seconds for Claude to run this. Same findings, same count, consistent across both runs. That's encouraging. Though SemGrep documented significant variance on an older version, so I wouldn't treat any single scan as the final word. Now let's see GitHub Action. I have got the same repo on GitHub with Anthropics open source security review action configured. The main branch has a clean app skeleton. I am opening a PR that adds all 10 vulnerable endpoints. The action triggers automatically. You can see it running in the check section. This is running on Anthropics open source Claude security review action. It uses my API key. I'll share the exact cost at the end of this video. This will take a few minutes to complete its run. It all depends on the complexity of your projects and the amount of file that it has to scan. Alright, the run is complete. And Claude added inline comments in your files. I can see the same findings as we saw in our terminal run before. And here's the final scorecard. The /security review command running locally, 10 out of 10. It caught everything. The GitHub action on pull requests, 9 out of 10. The same finding except the hard-coded secret that was already on main. Both tools caught the hard vulnerabilities. The race condition, the SSRF, the business logic flaw. Those are the ones that require understanding of code behavior, not just matching pattern. That was genuinely impressive. I work with security at scale with thousands of repository, and here is my take on this. First, I was genuinely surprised by the results. 10 on 10 on the local scan and 9 out of 10 on the PR scan. It caught the race condition, it caught the business logic flaw with negative cart quantity. Those are the kind of vulnerabilities that traditional static analysis tools usually miss, and that's impressive. Second, this was a control test with 10 planted vulnerabilities in an app. The real world codebase are bigger, messier, and have vulnerabilities that spans multiple files and services. SemGrep's benchmark on real world Python apps found a 14% true positive rate with an 86% false positive rate. My test was intentionally clear cut, but real world won't be that simple. Third, I got consistent results across 2 runs, but SemGrep documented significant variance on different runs, so I won't treat any single run as a final word whether the code is secure. And one more thing to keep in mind, Anthropics' own README for the GitHub Action states that it is not hardened against prompt injection, and they recommend using it only on trusted PRs. If you are running this on repos where external users also submit PRs, be aware of that. Bottom line, this is a strong first line of defense. So just add it as a layer, not a only layer for security. The vulnerable app that we use today is linked in the description. Fork it, run your own tool against it, and tell me what they catch. And if you want me to test the paid code review or the enterprise scanner, drop a comment below. I'm Yudi, signing off. Until next one.